Let's see the fourth problem. This is a very good problem. Like uh, unique median. An array B of m integers is called good if uh, when it is sorted, the value at m plus 1 by t, floor of m plus 1 by 2, is should be equals to the ceil of m plus 1 by 2. Uh, in other words, B is good if both of its median are equal. And in particular, like if m is odd, then both values are same. So if a sub array, like if the array B is guaranteed to be good if it has an odd length, means all odd length array is good. Now you are given an array of n integers and we have to count the number of good subarrays in A. Number of good subarrays. First, see that like all the odd subarrays is are good, and we have to find for even subarray, like even length subarray, like how many even length subarray are good. Uh, First see sample, like we n is up to 10 to the 5 and all the elements is up to 10 only. Like this is a very important point. See the second problem, like second sample, 1 10 2 3 3. Here like one of goods even length survey is this, because when you sort it, then it will become 2 3 3 and 10, where both the median 3 are equal. So how to uh, deal with this problem? First, what I will do is first, uh, like I will find all subarray and I will subtract from all bad subarray subarrays. Now, number of subarray is equal to number is basically equals to n into n plus 1 by 2. Yeah, plus 1 by 2. And we know that all odd length subarray are good, and we have to find only even length subarray which is bad. So let's, when even length subarray is bad, like uh, like the array should be like this: 1 1 2 and then 3 and 4 and then 5 when even we sort the given subarray. So you can see that always this the like the both median should be different. It means that there is a partition means like whenever we like first ly 2 elements, like let's suppose that the length of this subarray is basically L. Then the first ly 2 length subarray, like first ly 2 elements, like the consider the first half array, like first half part and the second half part. So you can see that these, like the last element of first part and the first element of right part, is basically not equal. So uh, what I am doing, like as all the elements is up to 10 only, so how many possible combinations should be there? Like here what can happen, like the possible medians are, let's fix this number, like let's fix this number 2. So then like I am finding that number of subarray having median equals to 2, like this number is equals to 2, and which is bad. So then the like we have to place something here, then something here, like something here, and then something here, and then 2 here, and then one element which is greater than 2, greater than 2. So greater than 2, and then 3 element more. So this should be the pattern, and this one should not be equals to 2. Now uh, how to deal with this? Like, let's suppose I am currently working on number 2. So what you do, like, replace the this array, like this array with, like, all the elements whose value is less than equals to 2, replace that element with 0. Like, replace 1 with 0 because it is less than 2 and equal to 2, and replace it with also 0, and replace it with 0 also, and 1 1 and 1. Like, all the elements which is greater than 2, replace it with 1. So now you can see that the bad survey uh, ha- has a very unique property, that the sum of this array should be equals to L by 2. L by 2. All other like array which is, if the array is good, then the sum should not be equals to L by 2. You can consider this, like, if the array is something like this, then it is good, because the middle element is basically equal. Middle element is basically equal in this case. I am considering only two, current median is 2. So like, when this is possible, like, if this is the case, then you can't form a partition here, like, in the middle. Like, it will be a good survey. So what we need to find is, basically, for all 1 to 10, like, consider that element to be median, and replace the array with this new array. Like, if you are working uh, currently on x, then replace all less than equals to x element with 0, and all greater than x element with 1. And now you have to just check the given subarray sum is equals to L by 2 or not. This is a solution for one subarray, but you have to find for all subarray. So how to do that? So basically, you are given a array, like array, long array like this, and you have to find for number of subarray which is bad. So let's fix the element x and do the same just you are doing here, like, replace all the elements less than equals to x with 0, and greater than equals to x, greater than x with 1. And what you have to find, basically, the number of subarray whose sum is basically equals to the length of that subarray divided by 2. So how can you do this? First make this array, this array. So let's suppose I have, let's take this sample, and let's, I'm considering currently element 2, like 2. So what I will do, I'll replace it with 0, and then this with 1, this with 0, and then 1, and then 1. Now I have to find, like, how many subarray is here bad, like this one, because its sum is 1 and the length is 2, and another one is this one, and one more is this one. These are bad subarray. So this is basically equals to, like, take the prefix sum of this array. So basically, prefix of I, prefix of r minus prefix of l minus 1 will give the sum from l to r, which should be equals to length, basically r minus l minus 1 divided by 2. You have to do this. Now if you process it further, then multiply the LHS with 2, then this will be prefix of times prefix minus 2 times prefix of L minus 1 should be equals to R minus L minus 1 and uh, take R to LHS, and so this will be equal to 2 times prefix of R minus R equals to 2 times prefix of L minus 1 minus L minus 1. So you have to find number of indices, like number of L and R which satisfy this condition. So how to do this? Let's make another array C whose ith element will be equals to 2 times prefix of I minus I. So now in this array you have to find number of I comma I j pair which is basically we satisfy this property C of I equals to C of j. You have to count this number of pairs I and j, but there is one catch, the like the we are working on only even length, so I minus j plus 1 should be even. Now you have to do this for all possible x, like from 1 to 10, but there can be overlapping case also. For example, here you can see that if you replace it, if you are working on currently 2, then this will be the case, and if you are working on 3, then this will be 0 1 0 and 0 and 0. So this subarray 0 1 and this subarray is counted in both the cases, so you have to take care of this. Now how to take care of this? Like if you are working on currently number element x, like for example here x is equals to 3, then you take only that subarray which contain 3. So for example, if you are here, then then you can take you can't take any subarray from here. Like if I am currently at index I am going backward and I am taking one by one subarray. Like if I am in 3, then I can take this subarray 3, then 3 2 and 3 2 10 and 3 2 10 1. If I am at 3, then I can take this one, this one, this one, this one, this one. So you have to maintain this also. Now after finding all this, we can subtract from the total subarray, and we finally get our answer. So let's see the code. Here I am taking input and I am taking vector. This is one indexing vector. I am working on one indexing, and this is the maximum element range, which is up to 10, and this is the I am initializing answer with total number of subarray, which is n into n plus 1 divided by 2, and this is minus, like we have to subtract this from our answer. Now I am basically which element is present, I am marking this, because if the number is not present, then it can't be a median for that array. So I am going from 1 to 10, and if it is not visited, then it is, if not present, then continue, and if it is present, then I am making that array 0 1 0 1 array. Like if the current element is less than I, then I am replacing, and then I am assigning v1 equals to 0, and else I am assigning with 1, and I have a function which count the number of subarray which is bad, and contain the current I also, current element also. So I am passing v1 v and current element. So let's see this function. So I am calculating prefix sum, and the array C, which is basically equals to 2 times prefix of I minus I, and I am maintaining 2 map for calculating this part, like for calculating this part. So basically I am initializing it with 1, and count is basically number of bad subarray, li is basically last index, and bool f is equals to 0, which means that if I found the current element x, like then only I can take that subarray. So if v of I equals to x, then I can now take the subarray. For example, if I am working on x and then subarray is like this So I can't take this Savere 5 or this Savere 4 5 or this Savere 4 4 5. I can take this Savere only 3 4 4 5 because it contains 3. I can take this Savere because it contains 3. I can take this Savere which contains 3. So I basically doing this, and this is a standard question like how to find pairs I comma j which satisfy some condition, and I am basically counting and finally returning the count and finally printing answer. So that's all.